You feel the pain of that outage. And I don't think that we share those stories enough. Cail, how did you bring down your Kubernetes cluster?
Hi, my name's Cail. I currently work as an SRE at a company called Octopus Deploy, where I'm in a team that looks after our internal testing and building and deployment infrastructure for our own product. And before we get into, do you want me to move that? Is all good? All right, cool. Before we get into kind of the failure that we talked about at the beginning, I kind of have to answer the question, like, what is Octopus Deploy as a product? Not to sell you on it, thank you, that's much better. Not to sell you on it, but, although they'd like it if I did. But you have to understand what it does and in particular how we test it for you to understand like why any of this is a problem for us. So Octopus Deploy is a continuous deployment tool. Customers use it to orchestrate their deployment pipelines for all kinds of things. And one of the kinds of things they can do with it is deploy to a remote SSH target, like a Linux box or whatever. And so we had to figure out, well, how do you test deploying to a remote SSH target? Well, first I'll start with how you shouldn't do it, which is have a set of medium-lived virtual machines in the cloud that have a shared key pair and have port 22 open to the internet. Don't do that. We stopped doing that a while ago. I think I see some steam coming out of security people's ears at the moment. It's all good. We set up a project to figure out, like, what should we do to replace that? Like, that's obviously sucks. Let's do something different. And we settled on Kubernetes, having our test harness launch short-lived pods that had a unique key pair, weren't accessible to the internet. I think that's a bit better. Here's an example of what that might look like. Now, is anybody here like a Kubernetes novice? You've heard of it, but you don't use it. You think it sounds like a Star Trek alien. Okay, cool. I'll try and explain some stuff as we go. Is anybody like an expert? You run it in production, you've seen it fail in weird ways. Ooh, okay, one maybe. All right. You can probably see the problem. Don't tell anyone, all right? We'll get there. So, 25th of August, 2022. We start getting some alerts in our kind of general infrastructure alerting channel. And this seems a bit weird. Tests are failing for reasons they probably shouldn't. We start an incident, we go in and have a look, and we see a whole lot of this. So if you're not familiar with Kubernetes, image pull back off is when your workload is trying to get started on a node in your cluster, but it can't get the container image that it needs to run. And not only can it not do that, it hasn't been able to do that for so long that the control plane is just saying, well, look, simmer down, we'll come back later. And that's a problem, but usually it self-resolves. This wasn't. So we went and dug a bit further and we saw this deeply cursed error message. If you've not seen it, but I'd never seen this before this happened. Just to decode this a bit, this is kubelet, which is the distributed worker in all Kubernetes nodes, saying that it can't talk to container D, which is the container manager, even though they're like next to each other. It's like, no, I can't talk to you. That should never happen. So we're like, okay, what do we do about this? We start looking in, and the problem is so bad that we can't even interrogate the control plane to understand, like, what's going on here? Can we delete stuff? No. What do? We do get metrics out, and we see that there are, at the moment, 700 pods trying to get scheduled in there. And we're like, this is not good. What do we do? In the end, we settle on expanding the node pool, because we have some levers outside of the Kubernetes control plane to do that. And we also make a choice to, while we're doing that, reduce the maximum pods per node from 250 to 125. Now again, you, sir, might be saying, well, why was it ever 250? Fair call. I'll come back to that. We also make a change to alter the timeout before retry in our test runner, because we're seeing this retry behavior where not only do you have hundreds of pods overloading a single node, but then it retries and another node goes down, and another, and another, and another. That's not good. We ship all these changes out. It takes an hour or two for this stuff to roll out because we have slow pipelines. Things finally calm down. Things get back to normal. We breathe a sigh of relief. We go home. The next week we run a retro, which is our usual practice. And we have a look at things, and we see some interesting things. First is that it turns out that the nodes that we were running for this particular kind of workload were much smaller than we thought. And these nodes were running spinning metal hard drives in the cloud, not SSDs, rust turning at speed. That's not good. We also saw, again, looking back through metrics, okay, yeah, we were seeing hundreds of pods arrive, and each of those pods had what's called an image pull policy of always, which means that every time a pod gets added to the node, it reaches out to the registry, tries to get an update on the image. Combine all those factors together, you're going to have a bad time, which we did. We also saw this retry pattern I mentioned. We saw that played out. We saw the patterns of failure and cascading out. And the only other factor we could sort of think about that might have led to things going wrong here was maybe there was like slightly more builds coming in than usual, maybe, but not like 20 times as many, like a little bit more. So we finish our retro and we sort of, okay, well done, we've understood the problem. And so that was it, right? I mean, it's not like I'd come up here in front of all of you and talk about not like one time, but 2 times that we had a Kubernetes. So 29th of November 2023, 15 months later, we get some alerts that kind of feel very familiar coming into that same channel. And tests are failing, they can't launch these pods. Okay, here we go again. Start an incident, go in and have a look. And instead we see this error message, which might be more familiar if you've done cluster administration for Kubernetes before. What this is saying is that the node is getting close to saturation. So this is before the point the first time around. And in particular, it's saying that I'm out of memory, or getting close to out of memory, I need to kick things out of my cluster. And it's this point where we might go, oh, exceeds its request of 0, it's not asking for any memory. Oh, no. So we ship a change to ask for some memory. That rolls out, things calm down, we breathe a sigh of relief, we do a retro. And in this retro, we struggled because nothing had really changed. I mean, in those 15 months, obviously a lot had changed, but the circumstances for this error hadn't changed. And so all we could think is maybe like not having done something since the last time contributed here. And you might be thinking, well, didn't you learn anything the first time? We did. We'd made changes. We mostly around pipeline safety, actually. We sort of said, okay, well, the first time it took ages for those changes to roll out. Let's invest in making that go faster and be safer. Those changes helped us to respond faster, but they didn't prevent the second incident. And it turns out our system was complex enough that it made it impossible for us to know at what point it was going to fail. Like we had an over-provisioner that was going out and trying to expand node pools ahead of work coming in to anticipate these spikes. We had a janitor that was going around and cleaning up stuff that shouldn't have hung around for too long. But those failed us entirely when, as it turns out, these tests just stopped deleting pods en masse, just decided to stop doing that for whatever reason. The systems we had couldn't keep up. Now, I used a word before that I want to dig into a bit, complex system. There's many definitions out there. Here's one I like. Complexity starts when causality breaks down. And you'll notice that's a physicist. That's not a software person. This idea of complex systems exists across heaps of domains, not just technology. And I want to put into your heads today, if there's nothing else, that direct causal connection between one part of your systems and the behavior of the rest might not actually be real. In the first incident, we had a situation with maybe higher builds than normal. In the second incident, we had a situation with tests failing to clean up after themselves. Now, some of you here might be tempted to call those two things root causes. If that's the case, I need to digress just a little bit. There's a children's book called Who Sank the Boat that I read my kids. It's by Pamela Allen. It's a very simple story. There's these 4 big farm animals, and they get in a boat one at a time, and then a mouse gets in the boat, and then the boat sinks. And it ends with the line, "You do know who sank the boat." Do we, though? Was it the mouse? Or was it all the animals together? Why weren't there any tests stopping them getting in the boat? Where was the change approval board here? Who let them get in there in the first place? You get my point, right? What caused these incidents? I think of those things as triggers, and I think focusing on the trigger is a bit too simplistic. It limits the kinds of things you can learn from how your systems fail. Who's heard of Occam's razor? right? The simplest explanation is usually the best, right? Do you know why it's called Occam's razor? I did some Wikipedia research, and William of Ockham, O-C-K-H-A-M, not that spelling, is attributed with that idea, but like he never actually wrote that down, not in anything anybody can find. Aristotle came up with an idea a lot like it, thousands of years before Ockham was ever alive, and the exact words that he wrote are attributed to someone called John Punch. So Occam's razor doesn't really apply to like why is it called Occam's razor. In medicine, they have a similar kind of idea, which is, when you hear hoofbeats, think horses, not zebras, right? But in medicine, they also have a thing called Hickham's dictum, which is a patient can have as many diagnoses as they damn well please. And so I'd like to humbly propose like Young's corollary, if you like, that's my surname, to Occam's razor, which is the simplest explanation, probably isn't the only one. And so in the time since these two incidents, like we've had a lot of thinking about complex systems and the way they fail. And I'm going to introduce some concepts here. I don't have time to get into any of them in depth, but I've got some references here. You can go look at them. One is this idea of drift into failure, where Sidney Decker, who's a safety researcher, writes about this, where systems seem to fail quickly, but when you look back, you see that actually what's been going on is like safety margins have been eroded by normal behavior over time. The second is this idea of the law of stretched systems by Hoffman and Woods in their paper, with a very long name there, but we call it Beyond Simon's Slice. This is the idea that in complex systems, any improvements to the capacity of them get rapidly eaten up by other stakeholders in your system. You might have heard this expressed as like work expands to fill the space provided or things like that. It's a studyable effect though, and not just in software, it's in everything. The third is the idea of latent failure modes from Richard Cook's How Complex Systems Fail. And this is that in any complex system, there are things that are just about to go wrong, but you don't know which one of those is going to be the one that gets you. You only know the cause of an incident after it happens, which seems like an obvious thing to say, right? But just to dig into hindsight for a second, I've just spent a whole bunch of time like illustrating like how not to do things, But the team that I'm in and the team that built these things made a bunch of reasonable decisions along the way. For example, 250 pods, right? We tested the hell out of that in the beginning, and it worked totally fine under all kinds of stressful situations. But what happened was the workload increased its memory consumption over a very long period of time, from 5 megs to 50 megs, and all of a sudden, 200 pods of that size in a very small node doesn't work for you anymore. What was reasonable in the beginning, it was eventually not reasonable, but that doesn't make the original decision wrong. You might find yourself looking back on decisions you've made or those in your team or your company have made. In those moments, try to be blameless. An author called Matt Davis writes a blog post called The Tao of Blamelessness, where he puts it really well, I think, that like blame is a natural human thing. We're all going to feel it, but if you really want to learn from your system's failures, you have to try to, he calls it, be empty of blame in those moments. So what did we learn? Well, over a 15-month period, things worked fine. So was the second incident a repeat? Like, what do we even mean by a repeat incident? Given what we said about causality, if you're in a retro for an incident and you're coming up with these ideas that maybe if we do X, Y, Z, so that this won't happen again, what do you mean by that? Can you guarantee that? Thinking about causality in complex systems, I don't think you can. So, although it might be slightly unsatisfying, I'd say that we learned that you can't prevent failure just by doing action items. You have to prepare for failure regardless. But if you do want advice, I would say that if you're running a Kubernetes workload, you need a resource request. It's a sensible default. I'm a hobbyist photographer, and there's this thing in photography called the rule of thirds, where you want to put something interesting on the top or bottom or left or right third of a frame. But there are plenty of great photos out there that break that rule. That said, you have to understand why the rule is there in the first place. So even though they're optional, use a resource request, unless you understand why you shouldn't. The other is you work in a complex socio-technical system. So socio-technical there, big word, sorry about that. The systems that you work on and are affected by require people and technology linked together to actually work. You can't take that apart. So you need to invest in understanding how they work. And then when you're looking back at failure, look for contributing factors for both failure and success. And that's how you're going to win in the long run. Thank you so much for your time. I need to thank all of my colleagues who both responded to these incidents and assisted in reviewing the talk, as well as my partner. If you like some optional homework, Richard Cook's paper, How Complex Systems Fail, is available at that website, how.complexsystems.fail. It's not a dry academic text. It's a wonderful read. If you do read that, or if you just saw this talk and you're like, wow, those are some great ideas and you want to talk about them, you can reach me there. I'm not on Twitter anymore for obvious reasons. And if this whole thing kind of interests you, my team is, as of today, actually hiring for an SRE. So if that interests you, come find me. Thank you so much.